Okay, today's lesson, 2.5, solving compound inequalities. The word compound means more than one. Usually, in fact, almost all the time, it's going to be two inequalities. My tip for you today, yep, I'm coming to you live on a little side camera there. Hopefully that's not distracting. My tip to you is that you have two options. Option one, you'll get two arrows, just like I drew, one going one way, one going the other way. It's typically called an OR statement. I tend to call them hockey sticks because usually it's winter time when we're studying this. Sorry, I forgot the K there. It'll come in just a moment. Or you'll get two arrows pointing at each other. That's called an end statement. And again, this reminds me of a hockey goal. So with these two tips, oh, and by the way, you will never get a scenario where your two arrows go the same direction, kind of like this, right? That won't happen. So if that does, it usually means a mistake has happened. Our first example, graph x is greater than negative 8 and x is less than 4. We're going to draw the number line. Since the problem is already solved for x in both cases, draw the number line, and all we need to put down on this number line are the negative 8 and the 4. First, put the 0 in the middle, 4 then to the right, and the negative 8 to the left. Our boundary point at negative 8 is an open circle because we're just greater than. On the right, it's filled in because we can be equal to 4. Now, since it is an AND statement, if you look back in the notes, the AND meant it was a hockey goal, so these two arrows should be going towards each other. And again, the statement says x is greater than negative 8, and then x is less than 4. So these two arrows meet up, forming a nice little goal. Okay, that's all there is to this problem. There's no simplifying, just circle the graph and move on to the next problem. Example 2. Here we have to both solve and graph. First of all, notice the OR. Again, that implies that we've got hockey sticks, which means they're going the opposite direction. There are two arrows. And in this case, we have to solve both inequalities first. So, again, look at the y in both cases. And then you got to start making decisions as to how you're going to get those variables by itself. First of all, on the left, we're going to add 5 to both sides. That will give us the 3y and a negative 3. Yeah, drag the inequality down. Now to get rid of the 3 in front of the 3y, we're going to divide both sides by 3. And that will give us y is less than negative 1. Now go to the right side, same thing. This time except you've got a negative 1, so add 1 to both sides. That gives you a 6. And then we have a 2y on the left. Getting rid of the 2 in front of the y, we divide both sides by 2. And that gives me y is greater than 3. Don't forget about that OR in between there. This is going to give us the hockey sticks. So again, place 0 in the middle. That's right, circle your answer first. 0's in the middle, 3 will be on the right, and negative 1 on the left. Again, we're looking at all the values less than negative 1, not including negative 1, so I don't fill the dot in. Likewise, on the right side, we're going to graph everything bigger than 3, not including 3. Okay, so there's our two hockey sticks. Circle the graph. We're done. Our last example, example 3. It says solve and graph. Notice in this problem that there is no and or. All we have is two inequalities in one inequality statement. When that happens, remember, this is not an or statement, this is an and statement. If you forget, it works out in the end anyways that you end up with the hockey goal, but on the front end it's nice to know what's going to happen. First of all, remember that you have two inequalities, so we have three sides to the problem. So when you do something, you have to do it to all three sides. The first thing we're going to do is find the variable, usually in the middle, then look at the two things we need to get rid of, in this case the -2 and the 1. First thing we'll do is we'll add -1 to both sides. Sorry, all three sides. This gives us -8, positive 8, excuse me, on one side. The inequality comes down as a less than or equal to, and the other one comes down as a less than. The -2x is alone in the middle, and -4 on the left. Now you've got to get rid of the -2. Again, we'll divide by itself, and this now creates 8. Oh, that's right. When you divide by a negative, don't forget, we need to flip our inequality symbols. So the less thans will become greater thans. 8 divided by -2 is -4. -4 divided by -2 is +2. And -2 divided by -2 cancels, giving me 1x. So now we have an inequality that is a little backwards because the larger number is on the left and the smaller number is on the right. Circle your answer. You don't need to rewrite it. But when you come to the number line, make sure that when you put, after putting 0 in the middle, put the -4 on the left and 2 on the right. Now again, we're looking at all the values that are smaller than 2, but bigger than -4. So this is what creates the hockey goal. The only thing weird about this hockey goal is that the -4 is included, but the 2 is not. So draw your little goal from -4 to 2, and make sure you don't include the 2. And there's your answer. Don't forget to circle it, and you're done. Have fun.